Area formula of a circle. Area is two-dimensional, right? So we do feet squared, inches squared, centimeters squared. So it's the squared one. Circumference is like the perimeter around the circle. Circumference is one dimension. So this is a one-dimensional formula, which is 2 pi r. It's r to the first power. Once that got straight in my brain about how area is two-dimensional, it needs the squared, and circumference is one-dimensional, so it's r to the first, then all of a sudden I remember the difference. So hopefully that helps. Okay, sphere. Volume of a sphere. Now this one, I don't know. Does anyone know the volume formula of a sphere?
Like
It's a fraction. 4/3
pi r.
pi r. And what dimension is volume? 3 cubed. Okay. So, surface area. Oh, this is interesting. I've never made this connection before, but I just thought about this because it works for both area and sphere. What's the derivative of this area with respect to r?
2r.
2 pi r. Interesting. Because it's like a polynomial. You're going from a cubic. If you take a derivative of a cubic, you get a quadratic. If you take a derivative of a quadratic, you get a linear. I've never made this connection before. I just saw it. So, yeah, the surface area is now two-dimensional. So it'll be 4 pi r squared. Yeah.
That's so cool.
Cool, huh? I just learned something myself. Ding, ding. Thank you. Alrighty. Oh, okay, so,
There's so much easier to remember.
yeah. So the cylinder, what's the volume of a cylinder? We have a bunch of circles stacked up.
So it's pi r squared.
Pi r squared times the height. Volume equals pi r squared times the height. So surface area,
2 pi r h.
can you take the derivative of that? We have two variables. This is implicit differentiation, right? What's the derivative? Chain rule. First, what's the first? Pi r squared. Okay, first. D last, what's the derivative of height? 1 plus last. D first, what's the derivative of pi r squared? 2 pi r. Let's see, wait. Yeah, this is just in a different order than how I wrote it. First, D last. 1 plus last. Wait, I have two because there's two bases. Oh, no. I'm missing a 2. I'm trying to figure out where it came from. There's supposed to be a 2 there. Because surface area, we have two circles, a top circle and a bottom circle, which is pi r squared. And the rectangle goes around, which is the height times the circumference, because the circumference is the width. Derivative-wise, I'm trying to figure out why there's a 2. Pi r squared. First, D last, plus last. Let's see first. Yeah, there's a 2. Okay, and this is because there's two bases. Okay, any right, there's my square base rectangular prism. Square base means the square is going to be length and width are the same, right? So S squared is the area of that. So the volume of a square base is S squared times, do you know what S means? Just the side length? Width and length are the same, so S and S. Times a bunch of squares stacked up on each other times by the height. Okay? Okay, one more though. We need to do the surface area of the rectangular prism. We have the top square is equal to the bottom square. Okay, so we have two of them. 2 of, let's see, this is written in, well, 2s squared. And how many of, since the height or the sides are equal, when you unroll the rectangles around, they're all going to be equal. How many rectangles do we get? 4, because this is S and S, S and S. This is the two-dimensional net. And all of those are width S. So we get 4 equal rectangles. So plus 4, and we have width S, but what's this side called? Yeah, it's the height. So S times H. And if S confuses you, you can put in width if you want. 2w squared plus 4 width and length, if you like that better. It'll be the same. Okay, what about, let's see, we have a triangular prism, and there are different types of triangular prisms. There's square-based triangular prisms, and there are rectangular-based triangular prisms. There's also triangle-based rectangular prisms. So, you have to know which one you're working with. Do you know what the volume of a triangular prism is, the formula? Same as a square-based what? Square-based, are you talking about a triangular prism, or are you talking about a rectangular prism?
S squared times H over 2.
So, what's the area of a triangle? Base times height, and then times by the depth. So that's the base. So depending what type you have, you times by the area of the base, the depth. Okay, because it could be a square base, it could be a triangular base, it could be a rectangular base. Okay.
Area. So for the square one, for example, it'd be times S squared.
Times what?
S squared.
For the square base? Yeah. Okay, so we're going to go through a bunch of problems. These are the steps finding optimization. Do you have your textbooks? Look on page 572, would you? Page 572. Okay, there's a couple other ones that they've listed on 572. We have cool little yeah, any cylinder with or prism with parallel bases. That's kind of cool. Cone or pyramid. Right, circular cone. So there's a few others if you need them. All right. So in order to solve these optimization problems, these are the steps we'll go through. Obviously, read the problem. That's kind of a given. Draw a picture so you know what's going on. Write formulas, and then solve. So let's just go through a problem, and then you can see the steps, what we're talking about. So number 1, a plot of land is bounded by a river on one side, and then the other 3 sides by a fence. What dimension should be used to minimize the amount of fencing required to enclose the area of 500 yards squared? So some key things you might want to underline as you read it. What's something important that we should underline? When you get your AP test, you should be marking it up. What's something that is important? There's a river, bounded by a river on one side. And 3 sides only have a fence. We're looking for dimensions. So, are we talking about 2-dimensional or 3-dimensional things here? 2-dimensional. So when we ask for dimensions, we need to find 2 of them. And we also know, and it even tells you area. Okay, let's draw a picture. What does a plot of land generally take the shape of? Or a rectangle, right? Could be a square, but we don't know that for sure. We know probably at least a rectangle. One of the sides can change the color. Has a river going through it. And we don't know if it's the long side or the short side, but it doesn't really matter. The area enclosed is how much? 500 yards squared. Okay? We're going to now write the formulas given for the optimization. They told us area. Do we know a formula for area of our shape? Do we know a formula for the area of a rectangle, guys? Yeah. Length times width. You wouldn't be in calculus if you didn't know that. Okay? And we know one of these. We know area. We know the A is 500, right? Okay? So we just need to solve for one of those variables. Sometimes it's easier to look at the formula you're optimizing. We want to know dimensions used for fencing. Where does the fencing go? Does it go all through the farm, the plot of land? No, where does it go? The perimeter, exactly. So our optimization is the perimeter formula. Okay? Perimeter equals, normally, 2L plus 2W. But in this case, we only have 3 sides. The way I've drawn it, let's decide, is this our width, probably? And the length. So we have 2W plus 1L. So either one of those would be fine to solve for. Which one would you like to solve for, L or W? Okay, let's vote. Who wants to solve for L? Okay, who wants to solve for W? Looks like L wins. Okay, solving for L, we get 500 divided by W equals L. Everyone good with that? So we're going to, I divided by, Now I'm going to take that L, and I'm going to plug it in, so that everything's in terms of W or P. P equals 2W plus 500 over W. Okay? So let's simplify P. What's P? Well, we actually might not need to simplify it. I think we can just leave it there. The next step is, we've done that. We substitute the variable into the optimization, write the equation in terms of one variable. Did we get it in terms of just one variable? All W's now? Now we're going to simplify. Yeah, I think we're done there. And differentiate. So let's find P. Well, actually, I'm going to, since I see a fraction, I'm going to move that W up so it's easier, because I don't want to do quotient rule. You can, but I don't want to do it. So this would be W to the what power? -1. Now let's take the derivative. P prime equals, what do we get? So I can just put even 2 minus 500 W to the -2 power. Okay? Or if you like to see that differently, 2 minus 500 over W squared. Okay? Next, this is familiar. Find critical points. Critical points happen when the derivative equals 0 or is undefined. So let's see when P prime equals 0 for critical points, and when P prime equals undefined. So we set P prime equal to 0. 0 equals 2 minus 500 over W squared. Can you solve that one out? What do you get for W? And now it doesn't come out nicely. So don't be rounding it unless the directions say round. Okay? So maybe minus 2 over. I notice they're both negative, so I can times by -1 and make them both positive. Everyone good there? I want to get the w out of the denominator, so I'm going to times it, both sides. W squared times 2, I'll put times by 2 over there. 500. Divide by 2, we get what number? So 250, W equals square root 250. Leave it. Don't type it in. Okay, restricted values. Any restricted values that we're going to have an issue with? When is p prime undefined? We have a denominator here. So when w equals 0. Okay, so if we know the width in yards, we need dimensions. Let's find the length. How do we find the length? Because we want your width and length. Yeah, don't we already know that length equals 500 divided by w? So length equals 500 divided by root 250. And that's not going to come out nicely, so we don't have any directions to round our decimal, so we'll leave it like that. What dimensions should be used to optimize the amount of fencing required to enclose an area of 500 yards squared? How would you write your answer in a sentence? So you'd say the dimensions required to minimize the amount of fencing of a 500 yards squared area are, the width is root 250 yards and the length is 500 over 250 yards. Okay, write that out in a sentence, please. Restate the question. Okay, number 2. Flip it over for number 2. Find the dimensions of a rectangular prism with a square base. What should we draw? Okay, so rectangular prism with a square base. So make sure it actually looks like a square. Make sure your squares are as congruent as possible. And then you just connect them. Connect, connect, connect the corners that match up. Pretty easy once you do. Start with the squares and then just connect them. Now we know it's a square base, so I'm going to label the base. You can use maybe L. If that's L, then this has to be L as well, right? Length. And then we have height. Okay, oh, and without a lid. No lid. That holds 100 centimeters cubed. So, without a lid, important, holds 100 centimeters cubed and be made of the least amount of the surface area. Well, you want to use the least amount of packaging, maybe, for this box. Okay, so, what's our given formula? We're going to have a given and an optimized. volume right here. It tells us centimeters cubed. So the volume of this normally is length times width times height, but our length and width are the same. So we can say L squared times height, because length and width are the same. They're both L. Everyone good there? Okay. And we know the volume is 1,000. Okay. So let's solve for H, and what do we get? H equals 1,000 over L squared. Okay, we're going to plug that into our optimize formula. We're not looking for a volume. What are we looking for? Surface area minus the lid. So that's two-dimensional. Okay. Ethan, can you help us out with surface area formula? Okay, and our S's in this case are L's. So 2L squared plus what? Okay, now that's with all sides, all 6 sides. And this problem specifically says one lid is removed. So which section is our lid? Is it the first term or the second term? The first term. So I'm going to change that to a 1. Okay, and we know L. No, we know H. Let's go plug in H. So surface area equals L squared plus 4L times H. H is 1,000 over L squared. And notice how everything on the right side is in terms of one variable. That should be your goal. Get everything in terms of one variable. So we have L squared plus 4. What happens to these L's? Cancel, and the exponent cancels. So I actually get 4,000 over L. That's 4 times 1,000 is 4,000 over L. Okay, it's all in terms of one variable. What do we do now? You have the steps on the front page, or what did we do in the last problem? Differentiate. Take the derivative of the surface area. Okay, so surface area prime. And we could also on this one, because I think it's easier to bring that L up than worry about the quotient rule. So I bring that up as a -1. Claudia, what's the derivative going to be? Great. Yep. So if we rewrote that, 2L minus 4,000 over L squared. Okay, that's SA prime. Now we look for critical points, which is when what? Derivative equals 0, and restricted values when the derivative is undefined. So we take the derivative and set it equal to 0. 0 equals 2L minus 4,000 over L squared. Now, this is what type of function? Well, kind of, except for L squared is in the denominator. Rational? Maybe, a little bit. Well, it'll be a little interesting here to solve this. Let's move the fraction over to the left side by adding it over. So we have 4,000 equals L squared equal 4,000 over L squared equals 2L. Could we do that? Multiply both sides by L squared? Would that help us get rid of that fraction? That's a great idea, I think. Times by L squared, times by L squared, cancel, cancel. Now I have 4,000 equals 2L to the third power. That's a great way to get rid of that denominator. Solving out, divide by 2. 2,000 equals L cubed, so L is the cubed root of 2,000. We don't round it because it doesn't say anything about rounding. And Hella, when do we have a problem with being undefined? Yeah, when the denominator is 0, right? So it's undefined when L equals 0. So the length can't be 0, which makes sense because you can't have a box with a length of 0 because then the box can't exist, right? It wouldn't be a box anymore, it'd be one-dimensional or something. Okay, we have critical points, we have restricted values. Now what? We have the length. Find the height. And the length and the width are both the length, right? So we don't even need to find the width. So we just need to find the height. And all it is plugging in. We knew that the height was 1,000 over L squared. So the height equals 1,000 over the cube root of 2,000 all squared. And the last thing before we write our sentence is I would put on units. Because this is a story problem after all. Are these balloons that we just found? Elephants? Centimeters. Centimeters on both of them. Okay. Then if you would write in a complete sentence, the dimensions we found.
Now, the length and the width are going to be the same, right? Because it's
Yep.
square.
Mm-hmm. Okay, so on your little homework slips, you have this is the 5.4. You have a problem set there. And we'll do the cylinder one next time. That'll probably be a good review anyway. But bring questions on 5.4. Let's see here. Yep, there's only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's about 11. The one that says optimization. Bring questions on those next time, and your mean value theorem worksheets are due next time. Any questions on homework or anything else? Alrighty. For Monday, yeah.